Now let's take another problem which is asked in year 2005. Engineering Mechanics get AME 2005. So here I am just writing the problem. A elevator consists of the elevator cage and a and a counterweight of mass m each. The cage and the counterweight are connected by a chain that passes over a pulley. That passes over a pulley. The pulley is coupled to a motor. The pulley is coupled to a motor. It is desired that the elevator should have a maximum stopping time of t seconds from a peak speed peak v if the inertia of the pulley and chain are neglected. Find the minimum power. Find the minimum power that the motor must have. So now here I am drawing the diagram. Pulley is there from which the motor is coupled, and there is a cage of mass m, and here there is a counterweight of mass m, and this is the velocity v, and this one is the chain, this one is cage, and this one is counterweight. Now we are interested in power. So if we first calculate the work done, means by applying the relationship between work and energy, and with the help of work done we can easily calculate power. So first let's say initial kinetic energy of system. So that is kinetic energy of cage plus kinetic energy of counterweight. Here we are not considering the rotational kinetic energy of pulley because inertia is negligible. So kinetic energy of rotational of pulley will be 0. So the initial kinetic energy of system, in that case kinetic energy of cage, that is 1 by 2 mv square, and for counterweight also 1 by 2 mv square. So we will get mv square. That is the initial kinetic energy of system. Final kinetic energy of system means finally it will be in rest. So final kinetic energy of system will be 0. So work done, we can say that change in kinetic energy of system. Work done on system, that is change in kinetic energy of system, mv square the 0, that is work done, W. So W we are having mv square. But now we are interested in power. So power is nothing but rate of doing work, that is W by T. So mv square by T. So power is mv square by T. So this one is the desired solution. So the correct answer is P will be mv square by T. Now let's take another problem which is asked in GATE 2005. Engineering Mechanics GATE ME 2005. Now I will write the problem. A 1 kg mass of clay, 1 kg mass of clay moving with a velocity of moving with a velocity of 10 meter per second strikes a stationary wheel and stick to it. The solid wheel has a mass of 20 kilogram and a radius of 1 meter. Assuming that the wheel and the ground are both rigid, and that the wheel is set into pure rolling motion. Pure rolling motion. The angular velocity of wheel. Find angular velocity of wheel immediately after the impact. Immediately after impact. So now we will solve this problem. I will again repeat the problem. Here the mass of the clay, that is 1 kg, is moving with a velocity 10 meter per second, and it strikes a stationary wheel and sticks to it. The solid wheel has a mass of 20 kg and a radius of 1 meter. Assuming that the wheel and the ground are both rigid and the wheel is set into pure rolling motion, so we have to find out angular velocity of wheel immediately after the impact. So this problem is based on the law of conservation of linear momentum. So let's solve this problem. So now we will take two conditions. First is before collision and second one is after collision. So this one is the mass 1 kg, that is mass of the clay. It is moving with a velocity suppose 10 meter per second in positive x direction, and here it is a stationary wheel, and the wheel here, that is a stationary. So the velocity is 0 and mass that is given 20 kg, and this clay is moving with 10 meter per second. It strikes to this wheel and finally it will stick on it. So after collision what will happen? There is a wheel as well as this mass. So now we are having 1 kg and 20 kg. So both will move together. It's a compound body and it is moving with a velocity suppose v. So now according to the law of conservation of movement, why we are applying the law of conservation of linear momentum? Because the net force acting on the system is 0. So I can write initial momentum of system. Initial momentum means linear momentum of system. So initially we are having the mass 1 kg moving with 10, so 1 into 10 plus 20, it is in rest, so 0. So initial momentum of the system is 10 kg meter per second. Similarly, we can find final momentum of system. Final momentum of system means momentum of the system immediately after the impact. That is after collision. After collision, we are having this situation here. So 20 kg and 1 kg will act as a compound body. So 20 plus 1 and will move simultaneously with velocity e. So now according to the law of conservation of linear momentum, I can write initial momentum of system equals to final momentum of system. Final momentum of system. So here I am having 10 equals to 21 V. So V equals to 10 by 21, and if we solve it, means if we divide 10 by 21, we will get around 0.476 meter per second. So it's a linear velocity, but here we are interested in angular velocity. So we know the relation between linear and angular velocity is nothing but V is to omega r. So omega is V by r. We know the radius of the wheel, that is 1 meter. So 0.476 divided by 1, so we will get 0.476 radian per second. So this one is the correct answer for this problem. The angular velocity of wheel immediately after the impact will be 0.476 radian per second. Let's take another problem which is asked in GATE 2004. Engineering Mechanics, GATE AME 2004. I'm just writing the problem here. A uniform stiff rod, a uniform stiff rod of length 300 mm, length 300 mm, and having a weight of 300 Newton, and having a weight of 300 Newton, is pivoted at one end, pivoted at one end and connected to a spring, and connected to a spring at the other end, at the other end. For keeping the rod, for keeping the rod vertical in a stable position, in a stable position, find the minimum value of, find minimum value of spring constant, spring constant A. I will again repeat the problem. In the problem, a uniform stiff rod of length 300 mm and having a weight of 300 Newton is pivoted at one end and is connected to a spring at the other end. For keeping the rod vertical in a stable position, we have to find out minimum value of the spring constant K. So now I will just draw the diagram here. This one is the weight here, and here it is hinged. This distance is given, that is 150 mm, and this distance is also given, that is 150 mm. This one is connected to a spring, of spring constant K, and we have to find out the minimum value of spring constant K. So let's this thing O. So now Let's displace the system by a small angle theta. So let's displace the system for a small angle theta. We'll be having this thing here theta. So let's say this distance is x, this distance is y. So I am just displacing the system by a small angle theta. So if we see this thing, I can draw a triangle here. Here we are having the point O. This distance is x, which is at a distance of 150 mm, and this is y, which is at a distance of 300, and this distance we can say that it is 150. So now we can easily see the relation between x and y by similar triangle property. So from similar triangle properties, I can write x by 150 equals to y by 300. So I will get y equals to 2x. So I'm having the relation y equals to 2x, and this system should be in equilibrium, so I can apply the conditions of equilibrium. That is nothing but algebraic summation of moments of all the force above. O should be 0. So here if we displace, the m will come here, that is the mass mg. So now this distance is x. So moment at O due to mg will be mg into x, and if you see the direction, it is anti-clockwise, so negative. Due to the spring force will act in that direction. The spring force value we have to find out, that is nothing but k into y. The spring force is k into y. So the spring force k into y, and the perpendicular distance between O and this spring force is nothing but 300. So this one is 300. I am just taking the linear dimensions. I am not going into the curved dimensions, or because we are giving the small displacement theta, and now we have to put sign. This due to this mg, it is anti-clockwise, so negative. Due to this ky, it is in positive direction, clockwise direction, so positive equals to 0. So now we are having mg x equals to ky into 300. So here I will write the value of mg. Mg, it is given, it is 300 Newton. Mg is given here, that is 300 into x equals to ky, and this one it is in mm, so I will convert into the meter, that is 0.3. So now if we further simplify, 300 into x, in place of y I can write 2x into 0.3. So we will get 300 equals to k into 0.6. So k will be 300 by 0.6, will come around 500 Newton per meter. So the correct answer will be 500 Newton per meter. Now let's take another problem which is asked in GATE 2004. So engineering mechanics, GATE AME 2004. I am just writing the problem. A rigid body shown in figure A has a mass of 10 kg. It rotates with a uniform angular velocity, angular velocity omega. A balancing mass of 20 kg is attached as shown in figure B. Shown in figure B, we have to find out percentage increase in mass moment of inertia as a result of this addition. So now I will draw the diagram for the clear understanding. This one is the figure A. Here is the hinge joint. This is figure A. We are attaching a mass of 10 kg, moving with some angular velocity omega, and this distance is given, that is 200. In figure 2, we are attaching a counterweight here, attaching the counterweight of 20 kg. This one is previous 10 kg. This is the hinge, and these distances are given. This is nothing but 200 mm, and this one is given, that is 100 mm. Now we have to find out mass moment of inertia. Means percentage increasing mass moment of inertia. So let's take a figure A. So now we will calculate mass moment of inertia about hinge. So we will get m r square is nothing but 10 into 200 square. So we will get 10 into 1, 2, 3, 4. Finally we will get 1, 2, 3, 4, 5 kg mm square. So that is the mass moment of inertia in case A. So we will denote it by I. Similarly, for figure B, we also calculate for figure B, that is mass moment of inertia about hinge. So there are two masses. We calculate 10 into something 200 square plus 20 into 100 square. So we know that 10 into 200 square will be 4, 1, 2, 3, 4, 5 plus 20 into 1, 2, 3, 4. So now we are having 2, 3, 4, 5 plus 2, 1, 2, 3, 4, 5. So total will come 1, 2, 3, 4, 5. That is kg and square. So let's say it's I2. So now percentage increase in I, that is I2 minus I1. I2 we are having 6, 1, 2, 3, 4, 5 minus 4, 1, 2, 3, 4, 5 divided by 4, 1, 2, 3, 4, 5. So I will be 2, 1, 2, 3, 4, 5, 4, 1, 2, 3, 4, 5. It will be 2 by 4. So 1 by 2 is 2.5 means 50%. The correct answer is 50%.